Here we have taken a question from the complex number, and the question reads as express the following complex number in the Euler's form. Here we have a complex number, and we have to express the given complex number in the Euler's form. And here let us solve this solution. Let 2 plus 2i is equals to r cos theta plus I sin theta. We know that the complex number can be expressed in the polar form as given that r cos theta in the form r cos theta plus I sin theta. It is also a complex number, and here so and it is also a complex number, and it is also a form of complex number. So from the equality of complex number we have here we will equate the corresponding terms, that is the real one with the real part with the real part, and this real part with the real part, and the imaginary part with imaginary part. That is the term containing I is often called as the imaginary part, whereas the numerical value without I is known as the real part. So from these two we can get r cos theta, that is this term multiplying r with the r cos theta and also with the r sin theta. We have two terms there. R cos theta is equal to 2, that is both of them are real part. Let us suppose this is equation 1, and also with the imaginary part with the imaginary one, that is r. If we multiply r with the I sin theta, that become r I sin theta. So we equate here the r sin theta is equals to, here we have r sin theta is equals to 2, that is equation 2. We have got here two equation, and by by solving these two equations we have to find out the value of r and here theta. So here squaring and adding equation 1 and 2, squaring and adding equation 1 and 2. Equation 1 and 2 we have, that is squaring squaring both the equation and adding the corresponding sides. That is, if we square this equation 1, it become r square cos square theta plus 4, and the second equation will become r square sin square theta is equals to 4. So adding the left side terms, that is r square cos square theta plus r square sin square theta is equals to 2 square plus 2 square. And here if we take r square common from these two terms, we have r square common, and cos square theta plus sin square theta is equals to, and here it becomes 2 square is 4 plus 4. We know that, or r square, we know that the cos square theta plus sin square theta is 1. So r square times 1 is equals to 4 plus 4 is, that is 8, or r is equals to root under 8, and therefore r is equals to 2 root under 2. And we have got here the value of r, and also now we have to find the value of theta. So dividing equation 2 by 1, we have to here divide the equation containing the sin theta by the another equation, that is r sin theta is equals to 2 by r cos theta is equals to 2, and here r cancel, and sin by cos is, we know that r sin by cos is tan theta is equals to 2, and 2 cancel from this side is 1, or theta is equals to tan inverse 1. Therefore we know that theta is equals to 45 degree, or we can also write it as pi by 4. Here now we have got the value of r sin theta and the value of r and theta. So we can express now 2 plus 2i is in the polar form is, that is r, we have 2 root 2 cos pi by 4 plus I sin pi by 4. Now we have expressed 2 plus 2i in the polar form, and also we have to express now from the polar form to Euler's form, and we know that, and also it can we know that if we have r cos theta plus I sin theta, we can write it in the Euler's form as ei theta. So it can be written in the form that is 2 root under 2 times, that is r times ei theta, that is 2 root under 2 ei, and here theta is pi by 4, which, and this is the answer. We have expressed the complex number in the form of Euler or Euler's form.